Hi guys, Ecto here, and welcome to the Teardrop. This is what the module will look like. It will be a white module with a teardrop on it, and a text at the top of the screen. This is the text we're going to be decrypting a bit later on. But first, we have to identify some things beforehand. So, without further ado, let's just get started. Step 1, who is crying? Take all the present indicators, unlit or lit, and sort them in alphabetical order. We just have MSA. We're going to take the first indicator from that list, and you still want to identify who's crying, so it's going to be MSA for this one. And we're now going to go across here and pick the first condition that applies. Even number of ports, 1, 2, 3, 4, that is also true. Since this is both based on edge work, this could be the same for this one. So we can note down we have orders. So we're now going to what's wrong. First, create a string that is basically just the alphabet. A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, U, V, W, X, Y, and Z. And then we're going to go top to bottom in this condition table. But first, check this condition. We have both a single parallel port and a lit bulb indicator is present. We have a parallel port but no lit bulb, so we can ignore this special rule. But let's go back up to here. The product of the number of batteries and the number of ports is odd. We have 4 and 2, which is 8, which is not odd. So you can ignore that one. So the digits in the serial number is prime. The sum is 20, which is not prime, so we can ignore that one. There are more batteries than letters in the serial number. There is 2 batteries and 2 letters in the serial number, so no. The serial number contains at least one of the characters from Teardrop. M and P do not. M does not appear in Teardrop, P does though, so we are going to be doing this rule. And in this case, one of these is going to be true. And in this case, the total number of modules is even. But this one isn't going to be true. So, we're now going to modify our string of the alphabet by the true statements here. So the first one we have here, take the letters of C, R, and Y, then place in that order at the end of the string. So take out C, R, and Y and put it at the end. And then take the letter in the position of the last digit. If the digit is 0, take it as 10. And then place it at the end. So the last digit is 5. So we take this F and put it at the end. We now have our string. We're now going to put our alphabet on top of it. Again, this is wholly based on edge work. It actually doesn't change between modules. So, what do we do now? Convert each letter of the name of the person crying into numbers based on their position in the alphabet. So we have Aldous. That's 1, 12, 4. 1, 12, 4, 15, 21, 19. And we do just, first we have to decrypt the word. Apologies for that. Convert each letter of the text from the top row to the bottom row to decrypt it. So in this case, we have bit AG, JR, XD becomes Z goes to F, A goes to A, G goes to I, J goes to L, R goes to U, X goes to R, and D goes to E. So the first one is failure. The second one so this is going to be the same key anyway. W goes to C, M goes to O, L goes to N, ZF, JL, GI, WC, and QT. So the second one is conflict. There's a table down here to tell you all of the words you could possibly get. So we're now going to move on to this step. So we're going to take the letters of the decrypted words, of the decrypted word for each one. So failure is going to be 6, 1, 9, 12, 21, 18, and 5. And we're now going to add all of these numbers together. Add all these together. Get 144. We're going to take this sum modulo 10, which you get 4. And press the teardrop on the last digit of the timer matches this number. So we're going to press on 4. And I just remember there is self music for this, so I'm going to quickly turn this up for the second one. So let's do the same for this one. So it's going to go from here, but for conflict it could be 3, 15, 14, 6, 12, 9, 3, and 20. So we get 4 again. So we're going to press it on 4. So that was the teardrop. Hopefully you now understand how the module works. It's the same across modules, so when you figure out for one, you've got it for everything. I realised I didn't think I had the sound on for the start, but when it first appears, you'll hear a droplet noise. Actually, I'll quickly load up another one so you can hear that. So you'll know if one of them's on your bomb if you hear this. That. Anyway, hopefully you understand how the module works. And I'll see you guys in the next tutorial. I'll see you later.